Let's jump into the next model, which is the Bohr's atomic model. Niels Bohr, a Danish scientist who worked with Rutherford, developed Bohr's theory of the atom. His model reinforced the idea of electrons orbiting the nucleus in 7 quantum levels or shells. Bohr based his theory on the measurement of the line spectrum emitted by hydrogen gas, using mathematical formulas to determine different energy levels by measuring their wavelengths. He proposed that electrons occupy the lowest possible energy level and only move up if the lower levels are full. Let's delve deeper into the planetary model of Bohr. Each shell has a specific energy level, and electrons cannot exist outside of these orbits. The closer the shell is to the nucleus, the smaller the energy of that shell. For an electron to move to another shell, it must absorb or release energy. The amount of energy absorbed or emitted is dependent on the difference in energy between the shells. The energy is radiated by the electron while jumping from a higher atomic orbital to a lower atomic orbital. When an electron moves to a smaller shell, it releases energy which we observe as light. The Bohr model of the hydrogen atom was the first atomic model to successfully explain the radiation spectra of atomic hydrogen. Niels Bohr introduced the atomic hydrogen model in the year 1913. It holds a special place in history as it gave rise to quantum mechanics by introducing quantum theory. The major postulates of Bohr's atomic model are: 1. In an atom, electrons revolve around the nucleus in some fixed circular orbits called shells. 2. These shells are also called stationary orbits. 3. Electrons, while revolving in these orbits, do not lose any energy. Also, each cell has a fixed energy associated with it, for the energy of an electron revolving in a stationary orbit remains constant. Energy is emitted from an atom only when an electron jumps from the orbit of higher energy to the orbit having low energy. 5. When an electron jumps from one energy level to another energy level, it radiates energy. The significance of this model was Bohr was the first to discover that electrons travel in various orbits around the nucleus, and that the amount of electrons in the valence shell may be used to define an element's characteristics. Bohr model and offer a more thorough comprehension of behavior of atoms and molecules. The limitation of the Bohr model is that it cannot explain the splitting of spectral lines when they are influenced by an electric field Stark effect and a magnetic field Zeeman effect. It did not explain how atoms can form molecules through chemical bonds. The electrons revolving around the nucleus are considered on a planar dimension in the Bohr plan. Inability to predict large-sized atoms and explain the spectrum of atoms with only 2 electrons, such as the helium atom. It violated Heisenberg's principle. This principle states that it is impossible to determine the precise position and momentum of electrons at the same time.